Our next sample problem is more quantitative aspects of acid-base chemistry. We want to calculate hydroxide, H3O+, hydronium ion, pH, and pOH. And what I'm going to kind of show you with this is what I call a around-the-block way of kind of calculating this. And we have 3 different solutions to do this with, so I'll kind of show it to you a couple of different ways. But this problem kind of brings in aspects of sample problem 18.1, because the first thing we have to do is realize that HNO3 is a strong acid. And so if HNO3 is a strong acid, that means we have a one-way arrow here, and we make 100% H plus and NO3 minus in solution. And so what this really means is that any concentration that we have of this is going to relate to the same concentration of H plus. So for sample problem, or for part A here, we've got 2 molar HNO3, which means we really have 2 molar H plus. So it's important that we understand that this is a strong acid, because then this problem becomes fairly straightforward to calculate, these 4 parameters. If this was a weak acid, then we'd actually have to do ice tables, and we'd need equilibrium constants and all kinds of other stuff that make the problem a lot more complicated. But knowing that we start with a strong acid makes this problem greatly simplified. All right, so what we're going to do is I'm going to show you what I call around the block way of kind of calculating this. We can convert H3O plus concentration to pH by taking the negative log of the H3O plus concentration. Remember, when I say H plus, it really is H3O plus, but for simplification's sake, we're just kind of writing H plus here. So putting negative log of 2 into your calculator, and again, you need to figure out in your calculator, is it one where you can write this whole string of math actually there, or do you have to actually put the number 2 in, press the log function, and then take the negative of it? So figure out and make sure you're familiar with how your calculator works. You should get minus 3.3 here. It's okay to have a negative value for pH here. It just means it's an extremely acidic solution. So we can then walk between pH and pOH by understanding that 14 minus pH is going to be equal to pOH. And what I'm really doing here for kind of this round the block here is I'm using these different equations. So we know, for example, that pH plus pOH equals 14. So rearranging that, we can take 14 minus pH to give us pOH. So in this case, pOH is going to be equal to 14.3. We can go around the block again and take 10 to the minus pOH, and that will give us the hydroxide concentration. So 10 to the minus 14.3 in your calculator should give you a hydroxide concentration of 5 times 10 to the minus 15th. And again, small value, not surprising when we've got a 2 molar strong acid solution that has a pH of minus 0.3. We're not going to have a lot of hydroxide in solution. And if we want, just as proof of principle, you can actually use the Kw relationship, and we can calculate the fact that H3O plus concentration is going to be equal to the hydroxide concentration minus Kw, which is 1 times 10 to the minus 14th. So if you take this number and you divide by the Kw value, we're going to get back to 2 molar. So convince yourself, again, that that's true. Oh, and I wrote this the wrong way again. I apologize. I was looking at the next problem, but again, if we want to solve for H3O plus, it's going to be Kw divided by, so it's going to be 1 times 10 to the minus 14th over 5 times 10 to the minus 15th. And again, that number subtracted by or divided by something that's even smaller will give us a number greater than 1. So this round the block way is kind of a way to interconvert and use all of these equations. I'm going to do the next problem by actually just going around the block the other way, just to make sure that you see the different permutations of this equation here. Okay, so we have a less concentrated solution of acid, so it's 0.3 molar, but again, that's still going to mean that we've got 0.3 molar H3O plus. So let's go, rather than going clockwise, let's go counterclockwise around the corner here. So hydroxide concentration is going to be equal to Kw divided by H3O plus. So we're going to have 1 times 10 to the 14th divided by 0.3. That's going to give us a hydroxide concentration of 3.3 times 10 to the minus 14th. Notice that it is larger than what we have here, and that's because we have a smaller concentration of H3O plus. Going this way, negative log of the hydroxide concentration is going to give us POH. So in this case, POH is going to be equal to 13.48. Going up this way, 14 minus POH is going to give us pH. So pH in this is going to be equal to 0.53. And as a proof of principle, you can go backwards here and show that 10 to the minus pH will give you back your H3O plus concentration. So 10 to the minus 0.53 in your calculator will give you 0.3. Again, just very quickly working through the last permutation here. If you're working through this to make sure you have the right answers, 0.0063 molar HNO3 will give us that same concentration of H3O plus. I'm going to take the clockwise approach here, and I'm just going to go through and make sure that you have the right answers here. Negative log of this value is going to give a pH of 2.2. Taking 14 minus the pH to give us POH gives us a POH of 11.8. 10 to the minus POH will give us the OH minus concentration. So for this problem, the OH minus concentration is going to be equal to 1.59 times 10 to the minus 12th. And then going and using our relationship between H3O plus, OH minus, and Kw, we can confirm that we get back to and walk around the block to our same spot, getting 0.0063 molar H3O plus. So again, some important equations to interconvert 4 important parameters for acid-base chemistry: POH, pH, and then hydroxide and hydronium ion concentration interconvertible by Kw. And then we can again use the P version of this. So 14 is pH plus POH. So different equations. This problem is made relatively straightforward by having a strong acid. We need to use some of these equations again when we have weak acids, and we need to figure out maybe what the pH, POH, H3O plus, or OH minus concentrations are.